Hello everyone. Today we shall discuss about solving an equation. Suppose constant equality, that is 8 minus 3 is equal to 4 plus 1. The equality of 4.5 holds since both its sides are equal. Each is equal to 5. Let us now add 2 on both sides. As a result, 8 minus 3 plus 2, 5 plus 2 is equal to 7. And here also 4 plus 1 plus 2, it is also 7. And again the equality holds, that is left hand side is equal and right hand sides are equal. Thus if we add the same number to both sides of an equality, it still holds. Let us now subtract 2 to both sides. As a result, 8 minus 3 plus 2. Let us now subtract 2 from both sides. As a result, left hand side is equal to 8 minus 3 minus 2, that is 5 minus 2 is 3. Right hand side 4 plus 1 minus 2 is equal to 5 minus 2, that is also equal to 3. Again the equality holds. Thus if we subtract the same number from both sides of an equality, it still holds. Similarly, if we multiply or divide both sides of the equality by the same non-zero number, it still holds. For example, let us multiply both sides of the equality by 3. We get 3 into 8 minus 3 or 3 into 5, that is 15. Right hand side 3 into 4 plus 1, that is also 15. The equality holds again. Let us now divide both sides of the equality by 2. 8 minus 3 divided by 2, 5 divided by 2, that is 5 by 2. Right hand side is 4 plus 1 divided by 2, that is 5 by 2 again. Again the equality holds. If we take any other equality, we shall find the same conclusion. Suppose we do not observe these rules. Specifically, suppose we add different numbers to two sides of an equality. We shall find in this case that the equality does not hold, that is both sides are not equal. For example, let us take again equality 8 minus 3 is equal to 4 plus 1. Add 2 to the left hand side and add 3 to the right hand side. The new LHS will be 8 minus 3 plus 2, 5 plus 2, that is 7, and the new RHS is 4 plus 1 plus 3, 5 plus 3 equal to 8. The equality does not hold. Hence, because the new left hand side and right hand side are not equal. Thus, if we fail to do the same mathematical operation with same number on both sides of equality, the equality may not hold. The equality that involves variables is an equation. The equality that involves variables is an equation. These conclusions are also valid for equations, as in each equation variable represents a number only. Right? So here you see. Here, a balanced equation is like a weighing balance with equal weights in the two pans. Here, consider one equation, that x plus 3 is equal to 8. We shall subtract 3 from both sides of the equation. X plus 3 minus 3 is equal to x, and the other new right hand side is 8 minus 3 is equal to 5. Here you say, why should we subtract 3 and not some other number? Try adding 3 with it help. Why not? Since this does not disturb the balance, we have new left hand side equal to new right hand side, and x is equal to 5. Right? 5 plus 3 is 8, and it is also 8. Right? Now, to confirm whether we are right, we shall put x equal to 5 in the original equation. X plus 5 and the 5 plus equal to 8, which is equal to right hand side as required. By doing the right mathematical operation, that is subtracting 3 on both sides of the equation, we arrived at the solution of the equation. Let us now take another equation, that is x minus 3 is equal to 10. Now left hand side, if you add 3 to both sides, what you get? Minus 3 plus 3, that is x, and new right hand side is equal to 10 plus 3 is 13. Therefore x equal to 13, which is the required solution. By putting x equal to 13 in the original equation 4.7, we confirm that the equation solution is correct. Left hand side of the original equation x minus 3, 13 minus 3 is 10, and this is equal to right hand side. Similarly, let us look at the equation 5y equal to 35, and m by 2 is equal to 5. In the first case, we shall divide both the sides by 5. This will give us just as y on left hand side. 5y by y, that is y, and new right hand side is equal to 35 by 5, that is 7. Hence, therefore, y is equal to 7. This is the required solution. We can substitute y equal to 7 in equation 4.8 and check that it is satisfied. In the second case, we shall multiply both sides by 2. This will give us just m on the left hand side, and right hand side is m. 5 into 2 is 10. Hence m equal to 10, it is the required solution. You can check whether the solution is correct. One can see that in the above example, the operation we need to perform depends on the equation. Our attempt should be to get the variable in the equation separated. Sometimes for doing so, we may have to carry out more than one mathematical operation. Let us solve some more equations in this with this mind. 3n plus 7 equal to 25 and 2p minus 1 equal to 23. Right? The 3n minus 1, if we add or subtract 7 from both the side, 3n plus 7 minus 7, 25 minus 7, that is 3n equal to 18. Now divide both sides by 3, 3n by 3 or 18 by 3, n equal to 6, which is the solution. Right? What should we do here? First of all, we should add 1 to both sides. 2p minus 1 plus 1, 23 plus 1, that is 2p equal to 24. Now divide both sides by 2, then we are getting p equal to 12, which is the solution. One good practice you should develop is to check the solution you have obtained. Although we have not done for this in above A, let us do it for this example. Let us put the solution p equal to 12 back into the equation. 2p minus 1, that is 24 minus 1, that is 23, which is equal to right hand side. The solution is thus checked for its correctness. In this way, you can solve any problem, right, in a variable. That means in a variable, we can add the same number, we can subtract the same number, we can multiply the same by same number, and you can divide the same number. Even then the equality holds for an equation, right? Next is some more examples. Here it is given. Right here 12p minus 5 is equal to 25. That is adding 5 on both sides of the equation. 12p minus 5 plus 5, 25 plus 5, that is 12p is equal to 30. Right? And dividing both sides by 12, we are also getting 5 by 2. Right? Putting 5 by 2 in left hand side of the equation, that is 12 into 5 by 2 into minus 5, that is equal to 25, which is equal to right hand side. Right? Now what we have done, adding or subtracting on both sides. Suppose add 10 on both sides. Right? That is 3p minus 10 plus 10 equal to 5 plus 10, 3p equal to 15. Right? Here also 3p minus 10, if you transpose minus 10 from left hand side to right hand side, on transposing minus 10 will becomes plus 10. We'll use this property in the next exercise. 3p equal to 5 plus 10 or 3p equal to 15. 5x plus 12 equal to 27. Transposing plus 12, on transposing plus 12 becomes minus 12. 5x equal to 27 minus 12, that is 5x is equal to 15. Right? Now here you can do also in this way. That is 4 into m plus 3 is equal to 18. Right? That is m plus 3, 18 by 4, m plus 3 equal to 9 by 2, m equal to 9 by 2 is equal to 3, transposing 3 to right hand side. Right? M equal to 3 by 2 is the required solution. Now check 4 into 3 by 2 plus 3, 4 into 3 by 2 plus 3 into 4 into 3, that is 2 into 3 plus 4 into 3, put m equal to 3 by 2, we are getting 18, and that is equal to right hand side. In this equation, minus 2 x plus 3 is equal to 8. We divide both sides by minus 2. As to remove the brackets in the left hand side, we get x plus 3 divided by 8 minus 8 divided by minus 2, that is equal to minus 4. X equal to 4 minus 4 minus 3, that is x equal to minus 7, the required solution. Check left hand side equal to minus 2 minus 7 plus 3 minus 2 minus 4, which equal to 8, which is the required solution. We can also find this from solution to make an equation. Suppose Atul wants values things differently. He looks at successive steps that one takes to solve an equation. He wonders why not follow the reverse path. The equation is the solution, and from solution to equation. Right? We will find the solution to equation. He follows the path as given. We start with x equal to 5, multiply both sides by 4, 4x equal to 20, and subtract 3 from both sides, 4x minus 3 equal to 17. Right? This is the required equation. If we follow the reverse path with each step as shown right, we get the solution of the equation. Right? Atul feels interested. She starts with the same first step and builds up another equation. X equal to 5, 3x equal to 15, add 4 on both sides, 3x plus 4 equal to 19. We start with y equal to 4 and make two different equations. Ask 3 of your friends to do the same. Are the equations different from yours? Yes, it is different. Is it not nice that not only can you solve an equation, but you can make equations also? Further, did you notice that the given equation you get one solution, but a given solution you can make many equations, right? I will solve the videos of exercises in the next video. Dear friends, if you like this video, please subscribe, like and share. Thank you everybody for watching this video.